LinkedIn Echo Chamber. This is ML's like Team Spirit. Today we have Will Hardman with us. Will, how are you doing?
Very good, thanks, John. Great to be
Excellent.
here.
Thanks for joining us. Thanks for the support. Will, I'm building a global map of my guests. Where are you dialing in from, please? Somewhere exotic, I hope.
Yeah, very exotic from Bristol in the far
A
west
cube
of
in Bristol.
England,
A
under the
cube
heavy
in
clouds.
a cube in Bristol. Thanks for that. Well, Will, this is your first interview with us. And when people come on for the first time, I have
Mm.
them introduce themselves. If you could take 60 seconds, please, and just start from, you're a data scientist. I should flag that to everybody. But if
Yep.
you could tell us like where you started and where you are today, please.
Well, John, this is 2024, so I'm no longer a data scientist. I'm an AI specialist,
Of
as we
course,
all
yeah.
are. So I guess I've been working for about 20 years in the field, and I started in management consultancy. And back then, what I did was called data analytics and operations research. And then we entered the big data era, and so I became a data scientist. And I founded a firm with a friend of mine, and we kind of grew that and ran that for nearly a decade. But for the last few years, I've been solo consulting and specializing back in where my heart is, which is machine learning and AI. And what I really love to do is help my clients think through, what this stuff is, how does it apply to their business? Is there a driving need for them to use it or invest in it or not? Because sometimes the answer is not. And then for those who have a good strong business case for actually wanting to invest or prototype or explore these technologies, I actually roll up my sleeves, kind of get my hands dirty, and help them build out some proofs of concept or actually some applications. So that's kind of what I do. Split my time up in that way.
Thanks, Will. So you're the real deal. You code still, but I'd help the businesses identify what to do and how they should do it. Well, this is what we
I
need.
think that's kind of important. Like when a field is moving as fast as it is now, you've kind of got to hit the road bumps yourself in practice, in order to know where they are and what the limitations of the technologies are, and to be able to sell to tell people, if you want to do X, Y, or Z, these are going to be the pain points. This is where your effort's going to be. This is realistically what you might expect at the end, and you can kind of get that honest opinion. But I think you can really only do it by suffering through some of the immature libraries and technologies yourself.
Well, Will, you're going to suffer through this interview today. So again, thanks for the support. I wanted you to come here to help us on a description of a methodology today. So I've had Nandu with me. He was
Right.
here talking about news data, and he was looking at something called topic models and trying to understand
Mm.
how that would help him understand specific topics within a data set. And he was looking at polarity within the topic. I've had George with me, who was looking at speech to text transcription in the contact center industry. He was also using topic models to try and understand what customers were talking about and therefore
Sure.
how could he show it to management. But what we
Sure.
didn't do on either of those discussions is talk about what the hell topic models is. So that's why you're here today. So I was wondering if you
Okay.
could kick off, please, and give us a tutorial on that today. Um, you know, we're all about simplicity here. So a bit of an overview of the methodology and what it is, please, to kick us off.
Cool. Well, I'll start with a disclaimer, which is that in 7 minutes, we can't really do justice to a field of this size. There are so many different ways of thinking about these models and building them. So we'll pick a few examples in the next 7 or 8 minutes, but by no means will we have covered all of the different ways you can think about topic models. So there's the disclaimer. I guess let's start from the position. You've given two great examples looking at news data and looking at customer contacts. Okay. In both of those situations, an organization has collected an awful lot of free form, what we call unstructured data. Okay. But there are many other examples. So you could, if you're a business that owns or produces a lot of content, for example, you could be a publisher of some sort. You could be a news publisher yourself. Or if you're an organization, for example, that has an enormous product line and you've got product descriptions for all of your different products, that kind of thing, you've got lots of unstructured text data. And the question is, how does somebody find what they want within that? So if a customer, using the last example, wants to discover what kind of products exist in a particular category, how do they go through if you've got thousands and thousands of these things? Well, you kind of got three ways you can approach it. You could get people to sit down and put metadata against all of your articles, all of your product descriptions, or whatever, and then you can tell people they can select from through the metadata. So they could have a taxonomy. These are all product descriptions of blouses, for example. So I can select those and I can now look at what I'm looking at. Or you could do something around search. So you could ask people, put in a couple of keywords and we'll search, all of our articles, news, whatever it is, and find what we're looking for. The search is great and kind of simple to do now because the tools exist. But the question is, what if you don't know what you're looking for? Or what if you want a general overview of everything that you have? And that's where topic models come in. If you've got no idea a priori about everything you've got and you don't want to go through the hassle of having to hand label it all, well, get a machine to look at it and group it up for you. And the machine will say, okay, you've got 1,000 articles about this thing, 1,000 articles seem to be about this other thing, another 1,000 articles seem to be about this other thing. And sometimes when you look at when we call them clusters or topics that a machine produces, they're not the ones you might have expected, right? So you can often learn something about the data you've got by allowing a machine to find the natural groups within it.
Well, I've got a
And that's
quiz question for you. I've got a quiz question for you. I've been racking my brains about a statistic, and I've forgotten the value of this statistic, but I'm hoping you know. It's a bit infamous, and because you use the definition for unstructured data, um, I think it came from IBM, who once made a statement as to what proportion of the world's data was unstructured and therefore less utilized. Can you remember the proportion? Because I can't.
I
I think
can't
it's
remember the
80%
proportion.
or 90%. Correct me. It's some huge magnitude like this, isn't it? Do you remember what it is?
I don't remember the statistic, but in my experience, it'll be the great preponderance of data will be
We are
unstructured.
going to grab it. We're going to add a screen print to this so that, like, regular folk watching this are thinking, John can't remember anything. He's got no recall. What I do know how to do is use Google search. So we're going to flash that statistic up. It's the unstructured data in the world is the largest by a massive proportion. So you're
Sure it
saying
is.
you're saying topic models then. So instead of having an army of people kind of labeling products, descriptions, categories, customer reviews, it's hugely laborious. Topic models is a method to begin to do that more systematically.
Yeah. So a topic model will essentially group up your data, split it into chunks, okay? And you can imagine doing this kind of hierarchically as well, so that somebody can then get an overview of, okay, these are all your products, and here are some natural groupings within them, and I can drill in and I can say, okay, I can keep going down. I can kind of explore what you have from the top down, rather than relying on dumb luck of knowing what I need to search for, or the overhead of having to get people to go through and systematically categorize everything. In which case, you're also relying on knowing a priori what the categories or the metadata tags you have to put in your data are.
Mm.
And that means knowing how people want to explore it. So topic models kind of get rid of those two problems for you.
So people can think of it as like clustering fragments of text into some kind of meaning based on the value of the text itself. What are some of the things you have to do, like as a data scientist, to tune this, make it work, understand the patterns? What would be like your workflow if you were applying topic models?
Yeah, so I suppose on the implementation side, you've got a number of choices about how you model your data. So traditionally, one way these models were thought about was as statistical processes. So I'd say until like 2018, 2019, most of the research was kind of in this area. And so the idea was this: you come up with a statistical model that describes how your documents are generated. And they tend to be very simple. They would say things like, um, a document is a collection of words, and these words are drawn from topics, and each topic has a probability of generating these kinds of words. Okay, so this is called it's called a generative model, right? So it's a generative model of how documents come to be, and then you say, if that generative model is true, then here is an algorithm which will find the different topics and label the documents with the topics. And then the goal generally is to find the most efficient algorithm you can, because they can get enormously mathematically complicated. So you try and find the most efficient model you can and use that to generate the data. One of the problems with that approach is that you start off by making this huge simplification, which is that a document is a bag of words, What I mean by that is it's literally we've taken the text, we've snipped each word out, and we've counted the number of times each word appeared. So it's a very efficient way to represent a document, but it has a big problem, which is that we've lost the ordering of the words. We've lost the fact that when they appear in sequence, they tend to impact each other. So if I have the words, I completed a research project, okay, the word project there kind of depends upon the word research before it. That tells me something about what kind of project this was. Whereas if I snipped it up into a bag of words, I've kind of lost that information. So that was one of the big problems with how we used to do it. Um, what the field has now changed to doing is much smarter. We use what's called embeddings, and these are based on neural networks. And an embedding is generated by a network that has learned by reading lots of text to be able to position words or sometimes entire sentences into a mathematical space such that those that are close in meaning are close to each other in the space. To visualize this, if you imagine you had a 2D graph like this, that would be a two-dimensional embedding space. And you can imagine putting the word king and the word queen in that space. They might be close together because there is some notion of royalty, which means those two words are similar in context. So that's one very simple way to think about how an embedding works. And the way that you use that in a topic model is you rely on the fact that if you embed two documents into this space and they are about the same thing, they should be close together. And so we can then use standard clustering methods to pull those things out at the end and say, oh, look, I've got these groupings in here. They're all close together in the embedding space. That's probably because all these documents are talking about the same things. They're using the same kind of text, mentioning the same entities. Maybe they're using the same sort of language, the same style. And so I can then find what's common across them. And that could become a topic. And that's kind of how we think about it today. And it's much more effective.
I love it, Will. In the archive, we have a video coming that's really the birth of a large language model. So I'm signposting this to the audience. We're going to go from Word to Vec through to BERT and this early phase before we start to dig into the attention mechanism, transformers, and try and simplify that for people. So let me try and just summarize what you said. The bag of words is over your data set. So in your data set, you have people can think of this as rows where you have text.
Mm-hmm.
And each piece of those text, is kind of, becomes a bag of words. And then across the entire data set, the topic model is going to figure out which ones are similar. What you brought in there with the embedding part is really solving for kind of text similarity. So one of the problems when you take text at face value is it might not be as clear that king and queen are related if that pattern is not well represented in your data. But if you use one of these embedding type models, you can tighten up that relationship is actually about royalty and so on and so forth. And that's how you can make topic models better. Will, is there anything else you can think of in terms of what's kind of cutting edge in the topic model space? We've got one more minute for you. So you've got 60 seconds for this one. But what is the very best thing happening in this area?
Well, I think one interesting area of research, so we talked about using embeddings to build topic models. And that embeddings are generally generated by these large language models like BERT, which are called encoder-only models, in that they convert text into mathematical objects. Of course, most of the noise in the last year has been about decoder-only models, generative AI models. And these tend to be much bigger and much more capable at understanding relationships in text. So a very active area of research and something that I've been working on intensively over the last year is how you build better topic models by replacing encoders with decoders at the front end. And I can tell you that it works extremely well.
Good. Will, you're not giving away any of your secret sauce other than that it works well. So keep that to yourself. Will, we're hitting time. Thanks for joining us. Thanks for taking us through that. Ladies and gents, this has been ML's Like Teen Spirit.